Okay. And we're going to go through this. All right, so the first question here is just saying that we've got a ladder and it's at a height of 2.5 metres up the wall. Whenever you've got these questions, I want you to sort of start thinking, okay, I've got Pythagoras' theorem says that the shorter side squared, the sum of those two, in other words, 2.5 squared plus 0.8 squared, is equal to the hypotenuse squared, which in this case is y. And then the only one which fits the bill is C. So the answer should be C. Yeah? Now, a lot of people ask me about question 2. Basically, if you wanted to represent Pythagoras' theorem as a, let's say if I've got a right angled triangle, and that right angled triangle, now I might call this A, this side length A, and this B. What they were saying is that if I was to create a square with a side length B, that square is going to look something like this. And if that's B, then this is also B, and that would have an area of what? What would the area of that? What's B times B?
B squared.
B squared. So that has an area of B squared. And this would have an area of A squared. And what are they saying? A squared plus B squared is equal to C squared. So in other words, what they're saying is if I had an area, a square, something that looks like this, that square is going to be C squared. And what they're telling us is that area is 34 centimetres squared. Now 34 centimetres squared is the sum of both of these squares. So therefore the answer to the sum of the squares of the other two sides is 34 centimetres squared. In other words, A squared plus B squared is...
How would you find what B or A is?
We don't know.
That's never going to be asked?
No, because we haven't been given either of those side lengths, so we simply can't know.
Yeah.
All right? It was a bit of an out there question, yeah. But we couldn't tell you what A and B is because we have only been given one side length. You need to know two side lengths to find the other third one. Yeah, well, we'll get to that. Just stick to the sheet today. All right, let me explain a bit later, okay? All right, I just wanted to go through the trigonometry questions. So can you fill this out as you go? You should have your sheet in front of you from yesterday. All right, now which one of these, it says here that which one of these would describe one of the sides? Well, which one of these does not have a hypotenuse? C doesn't have a hypotenuse because we need a right angle in order to find... So this here is a hypotenuse. This is a hypotenuse. Well, it looks like an equilateral triangle, a triangle of equal sides, but we don't have a hypotenuse. The only way we could have a hypotenuse is if we were to cut this triangle in half. That would be a right angle, and then that would be a hypotenuse. But that's not the situation. We do not have a right angle. Okay, looking at this triangle though, if we're told that D squared is equal to E squared plus F squared, is it a right angled triangle? Yes, because this theorem only applies for a right angled triangle. For a right angled triangle, then that's the only reason we can get Pythagoras' theorem to work. So you can't use that on any triangle. It has to be a right angle. So just a few concept questions to begin with, of which a couple of them were a little bit tricky to understand. Now let's have a look at this. We've got a diameter of a circle. So the diameter is this length, this line segment from C to B. So in other words, they're saying the diameter is this. And they're saying that, and it's a right angle. So in other words, this is a right angle here. Now we're asked if chord AC is 3.8 centimetres. So in other words, this side length is 3.8 centimetres. And AB is 7.9 centimetres. So that's 7.9. So what we're asked is to find the diameter. So once again, we can just write it out. We've got a right angle, so we can say that 3.8 squared plus 7.9 squared is equal to that length CB squared. Now I could evaluate what 3.8 squared and 7.9 squared are, but I'd have to take the square root of that. So in other words, CB, that hypotenuse, is actually the square root of 3.8 squared plus 7.9 squared. Now you could evaluate that first and then take the square root, but I'm just going to do that in one step. So we've got to do control, there you go, we've got the square root symbol, 3.8 squared. Now you can do, oops, don't know what happened there. Let's go inside the, so that's 3.8 squared. You can do this on your scientific calculator too. Plus 7.9 squared, and the answer is 8.76. Now if we have a look at here, it's to 1 decimal place. So 8.76, what would that be to 1 decimal place? 8.8 centimetres.
It's question 5.
Now quite a few of you were getting answers which were less than the other two sides. Remember that the hypotenuse has to be the longer of the three sides. So if you've got an answer which is less, then you might have done something wrong. Now we've talked about the rule about the relationship between the shorter side lengths. If I want to find b squared, well first of all let's write it out. Let's write out we've got 12 squared plus b squared is equal to 13 squared. And what we want to find is we want to find b squared. So in algebra, what do?
Take away 12.
We want to take the 12 squared from both sides. So in other words, b squared is equal to 13 squared, take 12 squared. We don't even have to work out what they are because the answers are in that form. So then the answer, therefore, must be b. They're asking for b squared, not b. If they're asking for b, then b would be equal to the square root of 13 squared, take 12 squared. Are there any questions so far? Now, if you've got a big one, I can hold off and we'll answer it once we're done with this. Now, we need to find b. So this time, there's a bit of a shortcut, isn't there? That b squared, isn't b squared equal to 5 squared minus 2 squared?
Correct.
Yeah? And we can evaluate what they are. B squared is equal to 25 minus 4. So in other words, b squared is equal to 21. But we don't want b squared, we want b this time. So b is equal to what? B is equal to the square root of 21.
Is something wrong? I did.
All right, so the answer for that one is 4.6, correct to 1 decimal place. Now you'll start to find that these are repeating ourselves, but once again, we could do two methods when we're looking at question 8. We're asked to find b squared though. So we can say that 6 squared plus b squared is equal to 8 squared. And we're trying to find, in this case, b squared for question 8. So let's work out what they are, or we could just say, well, we could work out 6 squared is 36 and 8 squared is 64, but let's subtract, I want to subtract 6 squared from both sides. So what does that leave me with? That's the same as 8 squared subtract 6 squared, which means that the answer is C. Bit of a repeat for a lot of these, as sort of more or less repetitive. But this one was a lot of people found tricky. First of all, it says that this right angle CA is equal to BC. Now I'm going to call that something like X. You don't have to do it this way, but this is how I would do it. So I'm going to call that X and X. Once again, we do the same thing. We can say the two shorter side lengths squared when we add them up. X squared plus X squared is equal to, be careful, let's use brackets here. Square root of 2, not the square root of 2, the square root of 2 squared. But what is the square root of 2 squared?
2.
It's 2. It's the same with anything. If I had the square root of 8 squared, the square root of 8 squared is equal to 8. Well, the square root of 2 squared is equal to 2. So what we've got is we've got x squared plus x squared is equal to 2. Now, how many x squareds do I have? I have 2 of them. So it's 2x squared. I'm collecting like terms. And then what do I have to do? I'm solving for x. So first of all, I divide both sides by 2.
But why don't you plus the pronumerals? Why isn't it 2x 4?
Because that's not in your index laws. That just doesn't work out. It's only when we multiply two indices of the same base do we add the power, not when we're adding them. So we've got x squared is equal to 1. What squared equals 1? 1. So therefore our side length is 1. In other words, we've got a triangle which is 1, 1, and this is root 2. Now what we sort of skipped is probably some of the applying, but they're just worded problems. It's really just solving the same things but with worded problems. We've got a kite which is at a height of, we don't know, but the string is 10 metres long. So we're basically saying that this side with the hypotenuse is 10 metres and that it's 8 metres away from him. So we've got a triangle which is this. We've got 8, we've got 8, we've got 10, and we're trying to find this height. I'll call it x if you like. So how do we find x? Well, once again, we could write it out the long way, or we could go method 1. Method 1, we could go x squared plus 8 squared is equal to 10 squared, or we could start to think and maybe cut out a step. Method 2 would be that if I wanted x squared, I can say I can subtract x squared is equal to the longer side length, 10 squared, subtract 8 squared. Or you could even go straight to that x is equal to the square root of 10 squared, take 8 squared. And what is that? 10 squared's 100. 8 squared 64. So what's that going to be? The square root of 36, which is equal to 6. So the kite is 6 metres high. Now, if you did method 1, it's no different. It's just that let's evaluate what 8 squared is. So that's x squared plus 64 is equal to 100. Subtract 64 from both sides, which gives me x squared is equal to 36. And then I'm taking the square root of both sides, so x is equal to 6. You had a question there, mate? Question 11. If the lengths of the sides of a triangle are in metres, the area of the triangle would be what? Metres squared. Yeah. So area is in square units, isn't it? Getting a little bit repetitive here, but once again, we need to find this distance x. And it's asking for the perimeter this time, so read the question. So it's x squared plus 8 squared is equal to 10 squared. That is x squared plus 64 is equal to 100. And x squared is equal to 36, which means that x is equal to 6. But that's not the answer, because the answer is asking for the perimeter. So the perimeter is 8 plus 6 plus 10, which is 24 centimetres.
Did you get it? No, you didn't. I got it.
Okay, so just remember we're asked to find that. All right, now we're starting to get into, as we get towards some of these are getting a little bit harder. And we're even going to look at some in 3D.
Yeah, I did that last night, but like, is that going to be the test? So 15.
So 225, which means that the side length is 15, which is 225, the square root of that. Now what they're saying is the area of that triangle is a half times the side length, which is a half times 15 times 8. Now if I evaluate that in my calculator, or I could say 8 times 15 is 120, a half of 120 is 60. It's the same thing. Yep. So therefore, the area of this triangle is 60 centimetres squared. Now, a little bit of algebra here is going to help, because it says that the area of a right-angled triangle is 6 centimetres squared. Shh, guys tapping at the back. Alright, so they're saying that this area here is 6 centimetres squared, but that has a base of 4 centimetres. Now they're saying calculate the length of the hypotenuse. So what they're saying is that the area is equal to the base times the height over 2. And that is equal to, well, the area is 6 and the base is 4. So 4 times the height over 2. Now how do we solve this for the height? Well, first of all, we could just do guessing and checking. If I multiply something by 4 and divide it by 2, I'm going to get 6. What would this have to be? What divided by 2 is equal to 6? 12 divided by 2, so therefore h would have to be equal to 3. Okay, now they're asking for the length of the hypotenuse. So I've got 3, 4. So once again, we could say that 3 squared plus 4 squared is equal to my hypotenuse squared. Now 4 squared is 16, 3 squared is 9, 25. What squared gives me 25? 5. So therefore the length of the hypotenuse is 5 centimetres.
I still think it's 12. Wait, so you're going to mine.
The trick to this one was that in order to find the perimeter, we need to find this. We need to find this side length here. Now, the only way we could do this side length is if we actually worked out this side length here. Oops. Pen's disappearing. The only way we can do it is if we work out this side length here and then this side length here, and these are all right-angled triangles. So we actually have to apply Pythagoras' theorem once, twice, 3 times. Okay, so it's no different, it's just that it's a little bit more work, it's going to take you a little bit longer. So let's start with the first one. I'm going to call this A, this length here. I'm going to call this B, I'm going to call this C. So what we're going to do is we're going to start with 1 squared plus 1 squared is equal to A squared. That's just using Pythag on this little triangle here.
Wait, 1 squared plus 1 squared is equal to 2, yeah.
So, okay, so that's 2. So therefore, what's A?
2.
What's A? Isn't A the square root of 2? From here, we've got another triangle and we've got a side length of 2 and root 2 and we want to find B. So let's do it. We've got root 2 squared plus 2 squared is equal to B squared.
So wouldn't the first one cancel it out? So it'll be 2 plus 4.
Yes, that's right. So this is 2 plus 4 is equal to B squared. So therefore we've got B squared is equal to 6. But that doesn't mean B is equal to 6.
Why is it 2? Why is square?
So I'm just going to hit resume now.
So do we figure out what root 6 is? Yeah.
No, not yet. Not yet, because in our last one we've got to look at this triangle over here. Now that triangle over there looks something like this. We've just found that this is root 6 and then this side length here is 3 and that's a right angle. And we've got to find what C is. So how do we do that? Well, we can say that C squared is equal to 3 squared plus root 6 squared. Now what is root 6 squared? What's root 6 squared? It's 6. And what's 3 squared? 9. So we've got...
Root 6 squared is 6.
It's because it's like rooted and it's rooted and squared, right? And so it just cancels each other out.
Yeah, resume here. We've got the perimeter And now we can start doing our rounding. The perimeter is equal to, well, it's equal to those 5 sides. Pentagon, 5 sides. So the perimeter is 1 centimetre plus 1 centimetre plus 2 centimetres plus 3 centimetres plus that root 15 centimetres, which we can do as a decimal approximate. Because
How do you,
Wait,
I don't understand how you round it.
Why is it 1 centimetre plus 1 centimetre?
so we've just added those together, and to 2 decimal places it's 10.87.
Where's
You don't know how to wrap
where's the 6? I've never been taught how to round off.
1 second.
That's not the perimeter, April. We needed to find root 6.
You said that. Okay, 1 plus 1.
So we've got 10.87 centimetres. Let's do some rounding. How would I round this to 1 decimal place? Come on, I don't want this to go for much longer. How do I round this to 1 decimal place?
10.9.
13 point,
Where'd you get 13?
13.9. This is question 16, April.
Oh.
So I'm looking at the second place. I'm looking at the second place and I'm asking myself, is that greater than 5? Yes, it is.
Yeah.
So therefore I'm rounding the first one up. Okay, so that's just a rounding question. All right, now this is where we're in your questions. We're looking at applications in 3D. Which one of these is true?
I had 2 because I didn't know which one. I had A and B. Please tell me it's one of those ones and not.
I'm going to resume here. So what we've got is we've got this. We've got a right-angled triangle, haven't we? Which one's the hypotenuse? The slant height. So isn't the slant height, that has to be greater than the other 2. So therefore it's saying that the perpendicular height of the cone, in other words, that's this guy here, we're saying that must be less than the slant height, because the slant height is the hypotenuse.
Hey, I got that right. No way.
All right, now look, I could continue going on and doing question 18. It's exactly the same, isn't it? It's just a repeat of skills. We've repeated this skill over and over again. What I think we need to do is perhaps try some of these other ones, like, for example, question 20. You can help me if you like. All right. We're going to finish that question 20 off next week. What is the index? Shh. The index is... The index is 4, the base is 3, and the numeral 3 is... What if I do 3 to the power of 4? What is that? 3 times 3 times 3 times 3, which is equal to 81. So if we...
have to answer them. I thought it was just saying the numeral 3 is...
The numeral 3 is... Yes, so the numeral 3 is the base. Yeah? Okay, what about if I was to write this in expanded form? That's 3 to the power of 3 times 5 to the power of times 11.
That's 11 confused me. It was like right underneath it. So
Yeah, because... All right, what is this in index notation? We have how many x's?
3.
Oh.
I don't even know. What is that? I don't get it.
Yeah, I didn't do that.
I don't know what... Yeah, forget that one.
Okay, so...
If h is equal to 10, what's h to the power of 5? Isn't that 10 to the power of 5?
Wait, which one? Yeah, my answer was
Yeah, is that...
100,000. I got.
Which is 100,000. Yes. 100,000 is correct. What number, when multiplied by itself, will give 16?
I didn't get that.
W to the power of 16.
I did 2, but it's wrong because I got like 8,000 something. How are you supposed to find that? Do you do 16 the square root of 16?
We haven't been through that yet, so forget about that one. Is this true though? Is this true? No, it's false. What do I do when I have two indices of the same base and I multiply them? What do I do to the powers? I add the powers. So that is false. The answer should be y to the m plus n. So that is false.
Mr. Underwood, how do you get the power but enter your own?
Now,
Yeah.
what about this one? If I have d to the power of something divided by d to the power of 10 is equal to d squared.
20.
No, it is 12 because I'd subtract the powers. So that is d to the power of 12. When I divide two indices of the same base, I subtract the powers. So that is d to the power of 12.
No, it's more like more new night dust.
When multiplying k to the power of 6 by k to the power of 8, what must we do to the powers? Yes, we add 6 and 8. So therefore the answer would be k to the power of 14. And I'm going to stop there for today.
Oh, can we do one more?